Smart refrigerator door. Aim. We want to make a smart fridge door that can tell us when it is left open. If the door stays open, a buzzer will ring and a light will glow to remind us. At the same time, a servo motor will move like the fridge door, showing when it is open or closed. Components used: IR sensor, BC547 transistor, LED, buzzer, 220 ohms resistor, breadboard, connecting wires, 9V battery, servo consistency tester, servo motor. Component explanation. 1. IR sensor, a sensor that uses invisible infrared light to detect if something is near. It sends infrared light out and checks if it comes back. When a hand comes close, the sensor output changes. Pin out, VCC positive, GND negative, out signal pin that tells if someone is near. 2. BC547 transistor, a small electronic switch that turns the LED on or off. A small current at the base controls a bigger current between collector and emitter. Pin out, flat face toward you, left collector, middle base, right emitter. 3. LED, a small light that glows when electricity passes through it. Pin out, long leg positive, short leg negative. 4. Buzzer, a buzzer creates sound when electricity flows through it. It has 2 pins, positive, plus, negative. In our project, the buzzer acts as the alarm siren. 5. 220 ohms resistor, controls and limits the electrical current. Used so the LED does not burn due to extra current. Pin out, no positive or negative. 6. Breadboard, the connection board used to connect parts easily. 7. Connecting wires, they join all components together. 8. 9V battery, the power source for the circuit. Pin out, plus, positive, negative. 9. Servo motor. A servo motor is a small machine that can turn to different angles. This makes it useful for gates, robots, and other projects where controlled movement is needed. The servo motor has 3 wires. Red wire connects to the battery, plus power. Brown-black wire connects to ground, power. Orange-yellow wire connects to the tester board, signal. The tester board uses these pins to control how the motor moves. 10. Servo tester. The servo tester board sends signals to tell the motor how much to turn. By turning the knob on the tester, the motor moves left, right, or stays in the middle. Pin out. It has pins onto side 1 is in and other is out. In S plus, these are input pins where the tester itself gets signal, power, and ground. Out S, signal this pin sends the control signal to the servo motor to decide its angle. Out plus, power this pin provides the positive voltage, usually 4.86V, to run the servo. Out, ground this pin connects to the negative side of the battery to complete the circuit. Connections. Step 1. Connect two 220 ohms resistors in parallel. To drop the voltage of 9V battery to 5V. IR sensor works smoothly at 5V. Step 2. Place the BC547 transistor on the breadboard. The transistor will act as a switch to control the LED. Step 3. Connect the IR sensor VCC pin to the common point connection of 2 resistors in parallel. The sensor needs positive power to work. Step 4. Connect the IR sensor G&D pin to the negative line of the breadboard. The sensor must return current to the battery to complete its own circuit. Step 5. Connect the IR sensor out pin to the base of the BC547 transistor. The sensor's signal controls the transistor. Step 6. Connect the emitter of the BC547 transistor to the negative line of the breadboard. The emitter must go to ground so the transistor can switch properly. Step 7. Place the LED on the breadboard. Connect the short leg, negative, to the collector of the BC547. The transistor will pull this point to ground to control whether the LED is on or off. Step 8. Connect the long leg, positive, of the LED to the positive rail of the breadboard. This will supply power to the LED. Step 9. Similarly, place a buzzer on the breadboard. Connect the short leg, negative, to the collector of the BC547. The transistor will pull this point to ground to control whether the buzzer is ringing or not. Step 10. Connect the long leg, positive, of the buzzer to the positive rail of the breadboard. This will supply power to the buzzer. Step 11. Connections for servo consistency tester. The S-pin signal is connected to the collector of the BC547 transistor. The transistor works like a switch. When the IR sensor detects something, it turns the transistor on, and this sends a signal into the tester to tell the servo to move. Step 12. The positive, plus, pin of the tester goes to the positive rail of the breadboard. This gives the tester the power it needs to work. Step 13. The negative, pin of the tester goes to the negative rail of the breadboard. This completes the power circuit and makes sure the tester and other parts share the same ground. Step 14. Now, we will connect out pins of the servo tester as follows. The S pin connects to the yellow-white wire of the servo motor. This is the control signal that tells the servo how much to turn. The plus pin connects to the red wire of the servo motor. This gives the servo motor its power. The pin connects to the brown-black wire of the servo motor. This is the ground connection needed for the servo to work properly. Step 15. Lastly, connect batteries. We are connecting to batteries in series because the servo motor needs more current to work properly. Result: the project successfully demonstrates a smart refrigerator door alert system. When the refrigerator door is left open, the buzzer rings and the LED glows, giving a clear warning to the user. At the same time, the servo motor, controlled by the servo consistency tester, shows the door's position by rotating to indicate open or closed. When the door is closed, the buzzer and LED turn off, and the servo returns to the closed position. This proves that the system can save electricity and keep food fresh by reminding us to close the fridge door. Precautions: always connect the battery at the end. Keep all components fixed tightly in the breadboard. Do not connect the servo motor or servo tester directly to a 9V battery. Always connect the ground of the battery, IR sensor, servo tester, and servo motor together. Conclusion: this was our smart fridge door. By using an IR sensor, a BC547 transistor, a resistor, and an LED, a buzzer, a servo consistency tester, and a servo motor, we made a simple system that rings when the door is left open. The buzzer turns off when someone closes the door and remains on when the door is left open. This project helps in learning about sensors, switching,